Quick, today is 2.7, families of functions, and we started with this a bit yesterday, just talking about the different graphs. Okay, so the three different graphs yesterday that we did, tell your neighbor what they are. All right. What's one of them?
Yeah, I knew that.
Okay.
I was going to tell you something.
Kinsey, what's one of them? One that we did yesterday. Huh? One of the three graphs that we worked with yesterday. Yeah, absolute value. That's one. Okay. It's another one, Marie. Linear, we talked about yesterday. What's the last one we talked about yesterday? Caden? Quadratic. There we go. All right. Tell your neighbor how you know in picture form that something's linear. Lily, what is it? Straight line. How do we know in picture form something's an absolute value? Go ahead, Keegan. It's a V shape. And now tell your neighbor how you know in picture form something's a quadratic. Ayla, what do you think? It's a U shape. Okay. So pictorially, I should be able to give you a graph, and you should be able to go, hey, that's a quadratic or absolute value or linear. Okay. Now the other three that we have on here, we have exponential. That's another one you'll cover this year. Rational is one you'll cover this year, and square root is one you'll cover this year. Okay. Note the pictures. Now this actually says e to the x. It could actually be any number to an x. The key is where your x is. Okay, your x is in the power position there. All right? Equation form. How do we know something is linear? Go and tell your neighbor. How do you know it's linear if it's an equation? No picture now. Oh, dude, a little quieter now. Chelsea, what do you think? How do you know something's linear? Okay, it's y equals mx plus b. The real key is we're focusing on x being to the power of 1. X is to the first power, or we don't see a power up there. It says f of x, which is the same thing as y. Okay, y to the power of 1. Now you learned last year y equals mx plus b. Okay, that's a good way to think of linear. That's definitely that's slope-intercept form, so we'll use that a lot. Equation form, how do you know something is a quadratic? Annalie, what do you think?
Because it's exponents.
Okay, it's exponent. Good, exponent to the power 2, and that's a key piece because when you get to advanced algebra, you study polynomials, which could be to the power of 3, 4, 5, okay, including x squared, which your graph starts doing some really crazy stuff then, okay? That little 2 there tells us it's a quadratic, x squared. So note the difference between your linear equation, x to the first, and your quadratic, x squared. Okay? How do we know something's absolute value? What happens to our x this time? Go ahead.
Absolute value bars. The x is inside the absolute value.
Your x is inside the absolute value. Okay, how many feel pretty confident if I gave you one of these equations, just that one, or that one, you could match it to which picture it'd go with? It's kind of our goal today. So with that, I'm adding 3 other graphs, and I'd have to say you have to start looking at where your x goes. To figure out what the shape of the graph of an equation will look like, look at where x appears on the right-hand side of the equation. It's a key piece. So if I'm looking at this, notice here x is to the first, here x went into absolute values, it's in a house here. Here, x, what happened to the x? Yeah, it's the power. It became a powerful x, right? Okay, it's a power. It's an exponential graph. Your graph does a little slide. Kind of goes upward here, or it'll go downward. It could also do this thing, like that. Okay? Quadratic, we have x squared. What happens in a rational? Where did x move? Caden?
Fraction.
Yeah, your x is down in the fraction. It's down in the denominator. It's in the basement down there. Okay? So this shouldn't be a terribly difficult thing, just identifying today. And here, x moved to a square root. It's inside our square root. This is your square root graph. This one right here is kind of weird because it does this, it has a branch here, and all of a sudden you get way so low, it jumps up to way up here all of a sudden. You get so infinitely small that all of a sudden it becomes infinitely big. Kind of weird, right? Anyone know why that happens? There's actually nothing, there's no solution right here. This is what we call an asymptote in this graph. We'll talk about it later, but something can't happen when x is 0 here. Why can't x be 0 in this graph? Dude, cool?
Because you can't divide anything by 0?
Yeah, if I make x 0, notice the 0 goes right here. And now I have 1 over 0, and you can't divide by 0. That's called undefined in math. Okay? Which means we get really small, and then we get to 0, and all of a sudden it's undefined. And then we get another number in here, like 1, and it's way up here. Okay? Kind of weird. Right? All right. Anyway, we'll get to that later in the year. Today it's just identifying the pictures. Okay. How do you think you got that? Let's see. Turn the page. Let's see how well we get it without looking. Without looking now. Now you can narrow your choices down, but do your best not to cheat yourself. Without looking, try to at least match up to, so like if you can't quite figure it out for this one, you're like, well, I know it's either A, B, or C. Then put A, B, C by it. Okay? Try to narrow it down to whatever choices it could be, and then take your best guess. Work with your partner on that right now, without looking at the other side if you can. Of anything, but I did see when I went over and talked to you guys back there, Mackenzie, I saw that you had these labeled. You had the names labeled, right? All right, so what's this one called? Everyone.
Linear.
This one's linear. We know it's linear. It's a straight line. What's this one?
Quadratic.
Good. So that's a good start. What's this one?
Square root.
Now, how many were able to get that one without looking? Okay. What's this one?
Absolute value.
Absolute value. Right? There's the V. Yeah. Okay, what's this one?
Linear.
Linear. All right. What's this one?
Quadratic.
All right. This one?
Quadratic.
Quadratics. Sad quadratic, right? It's opening downward. That's kind of sad. Okay? It's being kind of negative, if you know what I mean. What's this one?
Cubic.
This is cubic. Did anyone know that?
I just
Good. That's the one we didn't talk about. What's this one? Exponential. What's this one?
Rational.
Rational. Ratio. Means there's a fraction. Okay? What's this one?
Exponential.
Exponential. And
Absolute value.
absolute value. Also being kind of negative, right?
Yes.
All right, opening downward. Okay. With that being said, if you can do that, now you guys had that, right? Okay, if you can do that, now it just goes to eliminating equations. So when I go to letter A, here, letter A, square root of x plus 3. This is square root. Our x is in the square root. So that could either be this one. So a choice, this could possibly be A. Where's my other square root? There aren't any more. Dude, that means this one has to be A. A, all right. Dude, we're done with that one. Okay, well this, what type is that? B is, that's linear, x is to the first power. That means this one could be B possibly. Okay, nothing else on the top row. Second row, this one could possibly be B. Any others? No others. Okay. Which other one is linear? What letter? C? Yeah, C. Okay, so we either have B or we have C. Okay, one says negative 3/4 x plus 3 and one says 2x plus 3. They both have a plus 3. And the key there, that little constant term, this is something that you may want to add notes to. That little constant is when x is 0. If I put 0 in for x, what happens here? What's negative 3/4 times 0? 0. I'm left with what? With 3. What's 2 times 0? 0. I'm left with y equals 3. When x is 0, y is 3. That's called your y-intercept. And unfortunately, for us in this one, they both have a y-intercept of 3. That wasn't too helpful. However, that'll help out on some of these others. Okay? Your y-intercept here is 3. How do I know which one is B and which one's C? Brendan?
Well, you know B is the second row linear one because it's negative.
Good. It's negative. Negative means you're going down from left to right in linear. It's falling. You read your graph from top to bottom, left to right. Okay? So as I'm going from left to right, my graph is falling. On this one, as I'm going from left to right, my graph is rising. It has a positive slope. This one has to be C. But if you could at least narrow it down, you know you've got linear. Now if you could just remember falling from left to right is negative, rising is positive. It's like a rocket taking off or not taking off. That's not good. Okay? All right. Letter D, it's a quadratic. Which ones are our quadratics? Well, we've got a quadratic there. We've got a quadratic there. I'm going to scribble out these B's and C's so I don't confuse myself. We've got a quadratic there. We have 3 quadratics. So hopefully we have 3 quadratics over here. We have D. What other one? E and H. They all have that x squared. This one happens to be a negative x squared for E. Okay? E, D, and H. And where's my other one? Oh. Okay. Which one do I know for sure? This one's kind of frowning. What's that mean?
It's a negative.
It means your front term's a negative. Now, if you didn't know that, that's what it means. Okay? We'll talk about that more later this year, but if it's doing something different, like falling, that's a negative, or frowning, that's a negative. That means that one is letter E. E is our negative. This one's going E. How many got that one? Okay. Now we're back down to these two. We know E is not one of them. We have D and H. What's the y-intercept for letter D? Yeah, it's negative 3. It's the constant. That's your y-intercept. What's the y-intercept for letter H? Dude, it's our constant. It's when x is 0. If I put 0 here, it gets rid of that. If I put 0, negative 4 times 0 is 0. I'm left with f of x equals negative 5. Here I'm left with f of x equals negative 3. Which one crosses the y-axis at negative 3? The first or the second? First or second? First. This is letter D. This one is letter H. So there are little hints to you on which is which. Now, how many got D and H there? How many had narrowed it to D or H? You're like, I knew it was one of them. Maybe you just didn't quite get it. Okay? All right. Any questions so far? How many are 100% so far? Nice. How many have only missed 1 or 2? Good. Okay. Hopefully you're in the right family. It's bad to go to the wrong family. Like you try to go home one night and you go to the wrong house. They're like, oh, my bad. Dude. Okay. Anyone ever do that? That's good. Okay. Letter F. Letter F is a what type? Absolutely value. That could be this one. We have any other absolute values? Just the last one. What do we know about this last one? It's going to be a negative, right? Do we have a negative absolute value over here? Yeah, right here. So this one can't be f. It's actually I. What's our y-intercept here? Come on, we're trying to help you out here. What's our y-intercept? 3. It's when x is 0. It's 3. It crosses at 3. What's our y-intercept on this one? Negative 4. Dude, it's our constant. Hey, that also helps us there, but it's also positive. The negative positive should have gave that away. Y-intercept's your constant there. It's pretty cool. All right. Well, which one's cubic? We only have one cubic over here. That means x cubed. Brennan?
G.
G. Gee whiz. There we go. How many are still 100%? Wow. How many have only missed 2? How many have been in the correct family each time? Maybe you just had them switched. Okay, that's good. It's always good to be in the right family. All right. Exponential. We have 2 exponentials. Which ones are they? We have 3 equations left. Which 2 are exponential? KL. K or L. Which other one's exponential? This one, K or L. Now, this one's tougher because we don't have a y. I mean, we do have a y-intercept, but our y-intercept isn't added to the front. It's actually this thing right here. And unfortunately, they're both 2. Which one is a negative, so to speak, and which one's a positive? The one falling from left to right is a negative. That's a positive. However, I don't have any negatives or positives over here. Dude, this one's tough. How are we going to figure that out? Let me do this. Let's say x is 1. If I put 1 in for x right here, actually, rather than doing that, let's put 1 in for x here. If I put 1 in for x on this one, what's 2 to the first power?
2.
Dude, and that wasn't the resounding answer I wanted. What's 2 to the first power?
2.
It's 2. Okay, 2 to the first. So here I'm just testing a number. I'm going to put 1 in for x. 2 to the first is 2 times 2 is 4. So I should have an ordered pair of, what's x? 1 and y? Come on, help me out. 4. 1, 4. Which one's 1, 4? Is it first or second? It's the first one. All right. All right, so switching over to that side. 4 minutes to draw a picture and equation. They don't have to necessarily match, okay? But just a picture of what the graph would look like for each of those, and write what the equation would be. Yeah.
Can we just write like a...
All right. So go ahead and compare right now with your neighbors what you got. Tell them why you put the picture you did, and tell them why you put the graph or the equation you did. So on Brendan's, he's got x. Okay. Jake, why is this okay for linear?
Because it's y the right format, y equals x.
It's y equals x.
Plus.
So it's mx plus b. X has to be to what power? Annalie?
1.
Yeah, x has to be to the first power. Okay? Guys, I'm trying to get you ready for justifying what is what. So the reason here this works is x is to the first power. Okay? It's in the y equals mx plus b format, I think is what you're trying to think of, Jake. Picture-wise, how do we know this is linear? Cole? It's a straight line. Very good. Ryan, quadratic, how do we know this is a good one for equation?
Is squared.
Very good. X is squared. Highest power is 2. Go ahead, Audrey. Good. It's a U shape, so we know it's a quadratic because it's a U shape there. Now, as we progress and you start studying others, a U shape, if it's flatter on the bottom, could be a higher power. But for now, it's a parabola. Okay? Okay, right on here?
Yeah.
Okay. This is called a parabola. Parabola. All right? Lily, how do we know this is absolute value?
Because it's in a U shape.
It's in a, okay, so the picture. That would work for the picture, okay? How do we know equation-wise?
They're at the same value and equal to y.
Good, and the key here when you're describing this is x is in the absolute value symbols. Okay? If I had, for instance, y equals absolute value of 2 plus x, that's linear. Note the difference. X isn't in the absolute value here. X has to be an absolute value for it to be a V shape. All right, Patrick, how do we know this is exponential?
Because x is the exponent.
X is the exponent. Okay, Jaden Gents, how do we know the graph is good? Yeah, it's like a swoosh. It's like a slide, man. Okay? All right, very good. Okay, your assignment today, thank you, Brittany. Your assignment today, if you turn it over, quick review of domain and range. What does domain mean? X. What is range? Y. All right. So we see domain and range in different ways. We see it as a list of numbers in a set. Like x could be -2, x could be -1, x could be 0, x could be 1, and x could be 2. We could see it as a inequality as well. Now, I don't think I have inequalities on this paper. We didn't put the inequality ones. So today, you're just going to see it in set notation, your domain and range. How do you know if something's a function? When you're looking at it graphically? Patrick?
Was it the line test?
Yeah, the vertical line test, right? If I move this across, is number 12 a function? Nope, doesn't pass the vertical line test. It hits that graph in more than one spot on a vertical. Is number 13 a function?
Yes.
Yeah, it passes the vertical line test. Everyone, number 14, function?
No.
No, doesn't pass the vertical line test. How about 11? Yeah, it's a function. Brendan, can I borrow your paper again? Hey, really quick, just so you're clear, these graphs don't necessarily match this equation. However, is this a function? Yeah, it is. How do we know it's a function? Go ahead, Trinity.
It's in the right format.
Okay, it's in that format, but I could actually write this picture right here, number 12, in a format that looks like a function format. Kind of weird. In fact, this graph right here is y equals plus minus the square root, the negative. No, I can't do it. I don't know what that point is. But it's a square root graph. Okay? So that's not going to quite work. What's this make when we graph it? Okay? Straight line. And all straight lines are functions with the exception of ones that look like this. Vertical lines. Those are the only straight lines that are not functions. And that would be in the form of x equals something. Okay? Is this one a function? Yeah, it is. Why? Because it makes a... What graph is it going to make? It's going to make a parabola, a U-shaped. And all the parabolas are functions. Okay? Is this one a function? Who says yeah? Who says no? It's that participation thing again. So it's a yes or no question. So you have to make a decision. Who says yes? Who says no? Okay, the answer is yes. Why? Marie? It'll make a V shape, and all V shapes are functions. Is this one a function? A little tougher. Who says yes? Who says no? Now, who voted and they just weren't sure? It's okay to be not sure, but I still want you to pick a side. So who says yes? Who says no? The answer is actually yes on this one. Okay? It is a function. All slides like that are functions. All exponential ones like that are functions. Okay. Very good. Thank you, sir. All right. So you have your assignment. Go at it. You guys, I may have not done a good job at reviewing this real quick. Remember, for ordered pairs to be a function, you're looking at your x values. Each x has to go to a different y value. Or each x has to go to its own unique y value. So an x can't go to two different ones. So for instance, you're looking for repeated x values. Do any of your x's repeat? Nope, then this is a function. Do any of your x's repeat here?
No,
No? How about here?
yeah.
Yeah, which one repeats?
Negative 2.
-2. -2 goes to both 7 and to -3. That means if you were to graph it, -2 would go to 7. So I'm just going to plot where 7 is. Up there, we'll call that 7. And it would go to -3. It wouldn't pass a vertical line test. Therefore, that is not a function. So number 2 is not a function. Number 1 and 3 are. Okay, I'm going to let you finish up the rest of them there. Okay? That's just your quick review on functions. This was from what we did on Monday, so if you need to look at your notes, that would be a good thing to glance at. If you haven't glanced at the second page, you may want to do that real quick. Just so you recall. Remember domain. Domain is what? X. Ranges? Y. So domain is just a list of all your x's. Remember, range is just a list of all your y's. Okay? And then if you're finding your indicated value here, you're finding f of 3. X became 3. Here you're finding f of -5. X becomes -5. Remember, you're replacing x with whatever values here. Okay? Down here, you're plugging each of these in. So you're going to get 3 different answers. X is going to be 5, you're going to solve. X is then going to be 18, you're going to solve. And y, or x is going to then be -5, and you're going to solve. So you're inputting 3 different values to get 3 different outputs. Okay? So domain and range there.